show by the principle of mathematical induction that for all n belonging to the set of natural number n times n plus 1 multiplied to 2n plus 1 is divisible by 6. Okay, so how shall we proceed? So first we have to name this statement that n times n plus 1 times 2n plus 1 is divisible by 6. And we're going to represent this by p of n. So let p of n be the statement. So in essence, what we are saying here is p of n such that n multiplied to n plus 1 multiplied to 2n plus 1 is divisible by 6. And this is how we represent a mathematical statement. We're going to label this as 1 and keep it aside for the time being. Now we will check the validity of the statement by taking the first natural number n equals to 1. So let's check for n equals to 1. So this is the first step. So n equals to 1, we have p of 1 such that 1 multiplied to 1 plus 1 multiplied to 2 times 1 added to 1. Now what is this giving us? So this is giving us 1 multiplied to 2 multiplied to 2 plus 1, so that's 3, which is giving us 6. And we clearly know that 6 is divisible by, so that means the mathematical statement p of n is true for n equals to 1. So this is also going to be true for n equals to 2, n equals to 3 and other natural numbers, but we are not going to verify each one of them. And now what we'll do, we're going to straight away go to the mth term or the mth natural number. So let's say, let the statement p of n be true. We're assuming that this is true for n equals to m. In other words, what we are saying here, so we are saying here that let p of m such that, now all we have to do is replace n with m. We have m multiplied to m plus 1 multiplied to 2 times m plus 1 is also a true statement. That means this is also divisible by, this is divisible by 6. Fine, we're assuming this, and using this assumption we're going to check whether if it is true for the next natural number which comes after m, which is going to be m plus 1, if it is true for m plus 1 or not. In essence, what we are trying to do, we need to check that if we take p of m plus 1, then replace this m value with m plus 1. So we have m plus 1 multiplied to, so m plus 1 added to 1 will be simply m plus 2. To it we're going to multiply 2 times m plus 1 plus 2. So that means we have 2 times m plus 3. So we have to check whether if the product of m plus 1, m plus 2 and 2m plus 3 is also divisible by 6 or not. So this is all, this will be an attempt. Fine. Now how shall we approach? Now how shall we show that p of m plus 1 is true? So we'll use the fact that since p of m is a true statement, this simply means that m multiplied to m plus 1 multiplied to 2m plus 1. So this particular expression can be expressed as 6 times some natural number lambda. So we are considering where lambda is some natural number. So that doesn't matter what kind of natural number we choose. We're simply saying that it is divisible by 6. Now this is going to be number 2. We're going to use this fact. Now coming to our expression, so what we need to do is we need to show that this particular expression is divisible by 6. So now what we'll do, we'll take m plus 1 multiplied to m plus 2 multiplied to 2m plus 3. So we are going to make this expression divisible by 6. Now let's work with this particular expression. We're going to simplify it. So here we have m plus 1 multiplied to m plus 2 multiplied to 2m plus 3, but we're going to rewrite it as 2m plus 1 added to 2. Now simply rewriting this. Now what we do here is take the product of m plus 1 and m plus 2, and then we're going to distribute it with 2m plus 1. So we get 2m plus 1 added to, again we take the product of m plus 1 and m plus 2, and then to it we're going to multiply 2. Fine. Next what we'll do here, this time we're going to leave this intact. We'll only work with the first term. So in the first term what we'll do, consider m plus 1, but from here we're only considering m. And then what we'll do, we're going to take this m and multiply it with these two terms. So instead we get m plus 2 multiplied to 2m plus 1. Then we are left with this positive 1. So we'll take this positive 1 and to it we're going to multiply the product of m plus 2 and 2m plus 1 added to 2 multiplied to m plus 1 added to m plus 2. Now next what we can do here, so here we have m plus 2, but instead of m plus 2 what we can do, we can simply rewrite it as m plus 1 added to 1. Now this is done, this will become evident in the moment. So what we are doing here, we're going to take this m, we're going to multiply it with m plus 1 added to 2m plus 1. So we have 2m plus 1 added to, now we will take this m, multiply it with 1 and to it we're going to multiply 2m plus 1 added to these two terms. So we have m plus 2 multiplied to 2m plus 1 added to 2 times m plus 1 multiplied to m plus 2. The reason why we have done this particular manipulation, because now this m times m plus 1 times 2m plus 1, this can be simply replaced with 6 times lambda. So we have 6 times lambda added to. Now we will be combining these two terms by taking 2m plus 1 as the common factor. So if we take 2m plus 1 as the common factor, then from this term we'll be left with m added to, then from this third term we'll be left with m plus 2 added to the last term, which is 2 times m plus 1 multiplied to m plus 2. This is going to be equals to 6 times lambda added to 2m plus 1 multiplied to 2m plus 2 added to 2 times m plus 1 multiplied to m plus 2. Fine. So further simplification is now going to give us 6 times lambda added to. So here from 2m plus 2 we can factor out 2 to get 2 times m plus 1. To it we are going to multiply 2m plus 1 added to 2 times m plus 1 multiplied to m plus 2. Now from these two terms we can pull out 2 times m plus 1 as the common factor. So we have 6 times lambda added to 2 times m plus 1. Now since we have taken 2 times m plus 1 as the common factor, so we are now left with 2m plus 1 added to, so 2 times m plus 1, this is going to leave us with m plus 2. So we have 6 times lambda added to 2 times m plus 1 multiplied to 3 times m plus 3, which is now going to leave us with 6 times lambda added to, so we can factor out 3. So we have 3 times 2, that's 6. We have 6 multiplied to m plus 1. So this is also going to leave us with m plus 1. So we can square it to get m plus 1 whole squared. And finally, we're going to take 6 as the common factor. So we are left with lambda added to m plus 1 whole square. Fine. So here, lambda, we have already considered it to be some natural number. M is a natural number. So m plus 1 whole square is also going to be another natural number, which means that this entire expression, lambda, so here what we'll do, we'll consider this entire expression to be some another constant, let's call it beta, where beta equals to lambda plus m plus 1 whole square, which means that beta is simply some natural number n. Now 6 times some natural number beta, this simply means that the expression which we started out with, m plus 1 times m plus 2 times 2m plus 3, so this is divisible by 6. Now what is this expression? This is simply, what we have is m plus 1 multiplied to m plus 2 multiplied to 2m plus 3. So this particular expression came out to be equals to 6 beta. So we're saying that this is divisible by 6. So this is divisible by 6. And that finally proves the statement that P of m plus 1, this particular statement is divisible by 6. This is divisible by 6. So this is a statement which we have proved that it's true by the principle of mathematical induction.